All right, folks. So today we're looking at a little deeper into Avogadro's number and a mole, and just so you grasp what it means. So Avogadro's number is just a number. You know, nothing's fancy about that. Just it's literally this number right here. It's actually not exactly this, but this is good enough. Some people just put 6.02, and some people put 6.022. I think it does go further than that, but most people don't go much further than that, especially in high school level and stuff like that. So 6.022 times 10 to the 23rd power. That's just Avogadro's number. And that means that it also means, and what the relationship is if you have this many atoms or molecules, you would have one single mole of something. And that's why we usually talk moles. Like if you're saying, how much oxygen atoms do you have, you go, oh, I have 1.5 moles or something, because nobody wants to talk these gigantic numbers. But just for today, we will, just so that I know and you know that you know how to convert them if you had to. So if somebody said, hey, I got 9 times 10 to the, let's say, 23rd atoms of, I don't know, aluminum. I use aluminum a lot. Why not? Of aluminum. How many moles? So if somebody said, how many moles is that? How would you do that? Well, remember, obviously, I think if you look at this is 9 to the 23rd power. Avogadro's number is around 6 to the 23rd power, so this is more. So it's going to be more than 1 mole. It's not going to be 2 moles, though, because this would have to get to 12, which would actually technically be 1.2 to the 24th power. But given the fact that it's not, so let's look at this. So how do you convert this? What you do is you take how many atoms you have of something. Oops, that's 23rd. Let me just erase that, actually. So we have this many atoms, and or particles or molecules, whatever you want to say. And if we divide it by the Avogadro's number, this will tell us how many moles we have. It's just as simple as that, really. Now the cool thing is in your calculator you can cancel these out. Times 10 to the 23 times 10 to the 23, and it's just 9 divided by 6, and that's probably the easiest way to do it. Except sometimes they won't be exactly the same, so I should probably show you the long way to do it. So notice this is a standard calculator. Wherever you go, you're definitely going to probably need a scientific calculator that can handle powers. So we're going to go 9 times 10. How do you do times 10 on this calculator? Well, they're all different. Sometimes it's the letters EE, and this one is not. Sometimes it says times 10 to the something power. Like this one right here. You see this 10, but it's not quite that. I think it's not this. Yeah, it's this one right here, EXP. That E right here just means it's like times 10, okay? And then I'm going to say to the 23rd power. And I'm going to divide that by 6.022, and then I'm going to push that again, EXP right here, to the 23rd power. And that gives me almost 1.5 moles, 1.49 moles. So going back here, that equals 1.49 moles of aluminum. But did you notice that I didn't really care that it was aluminum? This could have been sulfur or anything. Did you notice I didn't really look this up on a periodic table? I don't need to. If I have this many atoms of anything, I have this many moles of that thing, so it really didn't matter. So don't let that confuse you right here, okay? Now, I'm going to use the calculator over here now, calculator. There we go. So I'm going to use the calculator here and see if I can do it here. So let me see. I think it might be this one. Let me see. 6. No, we're going to do 9. There we go. EXP as well on this one. 9 to the 23rd divided by 6.022 to the, and then here's E to the 23rd power is equal to 1.49. So it's the same thing. All right, good. All right, now let's look at one more example here. one more quick example, just pretty much the same thing. If I said I had 2.8 times 10 to the 24th molecules of CH4, how many moles? So how many moles is that? Well, once again, notice I don't really care if it's CH4 or whatever. I just care about how many molecules I have right here. This is what I really care about. And if I take 2.8 times 10 to the 24th power, that's a 4 by the way, 24, and divide it by Avogadro's number, 6.022 times 10 to the 23rd power, then we should get how many moles of stuff we have here. So let's go ahead and do that. We'll do it on here again on Google's calculator. So we have 2.4, then exp to the 24th power divided by Avogadro's number, 6.022 to the 23rd power is equal to 3.98. Oh, it was 2.8. Look at that. I didn't see that. 2.8. I put 2.4. Let's go back and fix that. 2.8 to the 24th power divided by Avogadro's number, 6.022 to the 23rd. 4.64. That's a 9 right here, so I'm going to round this to a 5. So 4.65. So 4.65 moles of CH4. That's how many moles we would have if you had this many molecules of it. Now going the other way, and let's just do one example of this one. If I had 2.2 moles of anything, I don't know. Let's go with sulfate or something. 2.2 moles of sulfate here. How many molecules is that? So I'm going backwards now. Well, before we divided, so now we're going to multiply. Remember, this many moles, and each mole is an Avogadro's number, so we'll just multiply them. 2.2, and you can see this actually works mathematically as well, but 2.2 times 6.022 times 10 to the 23rd. And this is Avogadro's number, and that's all you have to do. The proof behind that would be this is how many moles, and this is how many, like, I don't know, particles you have per mole, right? Or how many molecules per mole. So this is how many molecules or parts or atoms you have per mole, and then the moles, of course, cancel out. This is how many particles you have. So that's why it works. So just multiply the two together. And we could do that over here in the Google thing here. We'll go 2.2 times Avogadro's number, 6.022. And then don't forget to put the exp here to the 23rd power, which is equal to 1.32 to the 24th power. See the 24 here? So that's not a plus sign. That just means it's positive power. That's all. So to the 10 power to the 24th power, actually. So times 10 to the 24th power. So 1.32 to the times 10 to the 24th. 1.32 times 10 to the 24th power molecules of SO4. Not moles, molecules, right? Because we were in moles. Now we're in molecules. That's why the number is so big. That's how many molecules there are of that stuff. So that's all there is to that today's activity. If you do go back here, you'll see today's activity. Oops, it's not here. It's in a different one. There we go. And this is the actual worksheet. And you'll see you're just kind of converting. But notice that it says how many moles of glucose does this many molecules represent? Well, it doesn't matter if it's glucose or whatever. You're just taking this and dividing by Avogadro's number. This one, same thing. It doesn't really matter about this. You don't need to look this stuff up at all. We have a certain amount of molecules. That means we have a certain amount of moles of the stuff. And this one, it doesn't matter about the helium. We have 2 moles of it, and that means we have a certain amount of them, and that's all there is. Now, there is one trick right here. Let's see. How many sodium ions are there in 3 moles of this? Okay, so that's the same. How many molecules? Nope. Here's the trick one right here. This is the trick one, so be careful with this one. See, 1 mole of water gives you 1 Avogadro's number. So how many molecules of H2O would you have? You would have 6.022 times 10 to the 23rd power. That seems too easy for being the last problem, right? This is number 8. This should be the last problem. So 1 mole is easy. It's just 1 mole would give you 6.022 times 10 to the 23rd power molecules of this. But they didn't ask for molecules. They said how many atoms are there in 1 mole of this. So the trick is this. Find out how many molecules you have, right? So pretty much Avogadro's number, 6.022 times 10 to the 23rd power. That's how many of these you'll have. But they said how many atoms, and how many atoms are in one of these? There's 2 hydrogens and 1 oxygen. So there's 3 atoms here. So pretty much you're taking what your answer would be, timesing it by 3, and that's how many atoms there will be. So there's a bit of a trick just in the word right here. I noticed that one. This one right here also asks for atoms, but they're saying helium is an atom. It's just one thing anyway, so it doesn't really matter, right? But this one says how many atoms, and it's actually a molecule here. So you would have to find out, how many molecules you would have, which is really easy because it's only 1 mole, so you have 1 Avogadro's number of it. And then you have 3 atoms for every molecule, so you have to times it by 3. That's the only trick in the book there. Really weird that they did that. I caught that. I almost would have missed it myself. But I think the only thing that made me look at it twice was the fact that it was number 8. And I thought usually number 8s on these little assignments are like the hardest one. And this seems like the easiest one because it's like 1. And then it's like, okay, I don't even need to do math. 6.022 times 10 to the 23rd power, done. And I thought too easy, and then I read the atom part, and then I saw this is not just an atom, that's a molecule, and I said, oh, they want me to times it by 3. So that's all. So just be careful with tricks like that, okay? But that's the only one there. All right, so go ahead and do the assignment and turn it in, folks.